this data engineering session. So today it's gonna be mostly on the introduction of data engineering and then how this course will proceed further week and what we will learn and what you as a learner can expect from this session. So before starting, I will just briefly introduce myself. So my name is Arvind Patel. So I am Google certified data engineer. Currently, I am working as a data engineer at Lardal, Bangalore, and I have around 6 years of experience in the field of data engineering. So, so before I start, uh, anyone have any initial question, or we will just start? I think I will take it as a no. So I will start. So I have as I said, this is gonna be introduction session. So we will not touch in detail in anything. We will just give an overview about the data engineering. But in next classes are. Yep, I think there was some network issue. So I will repeat myself. So this class gonna be mostly on the introduction of data engineering and how you can use data in your project or how you can start career on the data engineering field. And with this AI in rise, so how data engineering become one of the most hot job in the market, and it's paying very good as per the current standard or market. So it's like, yep. So the agenda of the session, so few few 10 to 20 minutes we will talk about the what is data field and what are the major data field and industry, where we will cover about the position like data analyst, ML engineer, data engineer, AI engineer or data scientist, how these fields are different and what their role is. So if someone become a data analyst, what they do and what data engineer do in the industry. Now next we will go in why data engineering is the best field in the data field of the industry. And next is third topic, we will talk about what is data engineering. So I believe as this course is focused on the data engineering, so everyone should be aware about how data engineer is helping big organization or startup to build their data related pipeline and how they help other engineers in the building their product, which definitely used by people like us. Now next we will talk about the how the data has evolved and now how data is become one of the key component in the industry. And next topic will be talking about modern data stack, where we will cover what we will going to learn in this we will going to learn in the upcoming session of this data engineering classes. So as it say modern, so we will try to cover current industry tools, what is being getting used, how data engineering industry is moving forward. And then next topic gonna be data engineering life cycle. So you might be aware of SDLC, which is like software development life cycle. So similar to that, there is a data engineering life cycle where you know what all different stages or component are in their data engineering. So how as a data engineer you will know what you have to do, what you gonna do in once you start your job, or maybe you already if in any job if you want to switch to data engineering. So what you can expect and what industry expect from you. Now the next part is batch versus streaming. So in data engineering, mostly we create a pipelines, data pipelines. So generally they are gonna be two data pipeline, batch and streaming. So we will talk about the what is batch pipeline and the streaming pipeline. Then next, I gonna talk in detail about the career roadmap in data engineering, and then we will touch about the some industry use cases. And then next, at last, we will take some questions and answer from the audience. So now it's time to talk about the major data field in industry. So now, so in the older days, what used to happen is that generally the software developer were like those who are good in developing the APIs, or maybe front end developer, like who develop this UIs where like as a user like us who go and click. But as the industry grows, so it there were a lot of data was getting generated. So industry realized that we need experts in the data. So now different roles comes in the picture. So before directly going to data engineer, I will talk about the like the data analyst and data scientist and ML engineer. Then I will talk about the data engineer, how why data engineer is best out of them. So first, let's have a look on what data analyst is. So a person who is good in this SQL, Excel, Power BI, Tableau. So like I believe most of you had used Excel. So it's a like I believe like if you are in the CS or any nowadays, like Excel is a tool which everyone use. So it's similar to it Power BI and Tableau. So Power BI is like a visualization tool. So it is from the Microsoft. So any reports which we create, it might be sales report, it might be your marketing campaign report. So these are created in the Power BI or Tableau. Both are similar tool in terms of function. These are like, so if you see this Google image, so these are one of the report someone might have created, like sales report. So here like a business holder or stakeholder can come and see how their sales are doing, in where, like what products and all. So they are, so now to generate these kind of report, you need a data, and data analysts are expert on creating these report. They are expert in the Excel, and they are expert in telling about this report. Like they're gonna be responsible for numbers, how these numbers are generated, and these data analysts generally work on the historical data. They don't predict anything. So the next role come is data scientist, which is basically, it used to be very hot role. Like at least when I started learning data, it started data engineering or data field. So I also wanted to go in the data scientist field. But then with time, I realized that this this role is more like a experimental role. So in my experience, I have seen that data scientists build different statistic model and machine learning model, but they never go to production. So this job itself is like not a stable job. But at least on this software development industry, for other industry where actually you need a research data scientist, is a good job. But nowadays, like with coming this LLM model, open AI, and like this anthropics, so no one is building their own model because it's require a lot of resource, and there's a lot of go and forth in between this. So what exactly data scientists do? So data scientists take the data from the data engineer, they build a statistic model. So there are like G score statistic, and there are probability model, like there's are A/B testing. So I don't know if some of you have noticed that if you open a website, so sometime it's gonna show some feature to you, but to other it's not gonna show feature to them. So this come under the A/B testing. So this we do. Just give me a second. So before I proceed, I wanna confirm, like, everyone is okay with English, or should I I can talk in Hindi and English both in between. What gonna be preference? You guys can type in chat or unmute yourself if anyone want to me to explain in the Hindi, or if they are not very comfortable at English yet currently. So also it's completely okay. So it's these things are for your learning, so it should be as per your convenience.
I'm comfortable in both, so like we can proceed in English or Hindi.
Most of the time I will keep my. And you was saying something?
Yes, sir. I was saying that I'm comfortable in both. Like we can proceed in English or Hindi, anyway.
Okay, yeah, sure. So I will be switching in between Hindi and English. So yeah. Yeah, so as I was explaining about a data scientist role, so now the A/B testing is basically, so these kind of tests are done by data scientists, and they get this data and then they create a report and they present to the stakeholder, like how this feature is good and how it initial feature it doesn't. So other than, there are a lot of G other testing, G score testing and other stuff. But again, it's required a good knowledge of mathematics and statistics. So you need to be very good at the math and statistic, and lot of thing here we do experimental. So now sometime, like, business holder or stakeholder who actually have to put money, so they don't want to put money on which can be failed. So that's the reason data scientist role become like a not a stable role nowadays, because due to rise in the LLM model. So role like ML engineer, AI engineers comes in the market, where what exactly ML and AI engineers is. So ideally they will deploy model built by data scientist, or maybe they will use open API model, or maybe anthropic model, and they will fine tune it. From fine tuning, it's basically they take the model and they change the some parameter and they make it for your domain. For example, nowadays you might see there are a lot of chatbot in the websites. So most of them are not built from the scratch. What they do is basically they take open AI model, and then they fine tune it, and they make it aware of their domain. For example, if any chatbot is from the medical domain, so, and maybe like tomorrow any pharma company want their chatbot, so they will fine tune to answer the question for the pharma related product, not for the any answer for, like, maybe I go and I ask, like write a code, but they will fine tune as such a way that someone go in this kind of question, it will just fall back to some normal error that this is not allowed. So that's what ML or AI engineer do. So they fine tune the model, then they deploy it. Now uh, the role like data architect. So to data architect role is for someone who have like 15 plus of year of experience in the field. So anyone can become the data architect, but they need to go with this path, like they need to go with data engineer or data analyst or data scientist path and then become data architect. So when you can become the data architect, when like you already have like 15-20 years of experience, you know different uh, technologies, and then you know how to create a data infrastructure. When I say data infrastructure, it include everything. So it include different data engineer, data analyst, data scientist, and ML AI engineer and data architect guide them how they should build their uh, pipeline or maybe reporting, how each component will be connected with data, these different of thing. Now they are expert in data modeling, and nowadays one of the major requirement to know the compliance. So those who don't know the compliance, so in the industry you need to follow certain rule which is from the government or maybe from the like if you or if your organization work in multiple region. For example, like you have business in the Australia, you have business in the US, now you have business in the Europe. So they need to know their compliance. From the Europe, they generally we follow this GDPR. So I will just reshare my screen to something else. Yep. So basically GDPR is nothing, just how user data need to be protected and what level organization can use the data of the user. So so once you become the data architect, so you need to create a architecture on the basis of these different compliance we have to do. So it's a good role, but it's require very high number of experience. So it's not for like people like me who just have 6 years of experience or who might be entering in the industry. But yeah, but it's a very good role. Like if this, but it's also the last stage of your career in this data field. Now I will come to the role which we gonna focus in this session or on this course is data engineer. Now, da- data engineers are the enabler. Why I am saying data engineers are the enabler? Because data is scattered everywhere. We use app, mobile app, then there are websites also where we use it, and then there gonna be excels, and there gonna be offline events where uh, generally like offline events are those where we create our booth and then we promote our product. So what the role of data engineers, so they get different pipeline to collect this data and put it in some centralized system, so it can be further used by data analyst, data scientist, and ML engineer to do their stuff. With- Without data engineer, uh, these data analyst, data scientist, ML engineer cannot do anything. This is the one part of the data engineering. Now, as it's a engineering, so it's also open you to work on data infrastructure, which is basically you will be expert on the clouds technology like AWS, GCP, or maybe Azure. And then now Databricks is also in the picture, which is more focused on the data related product. So you will also learn the cloud, where you will focusing on the how to create a database, how to optimize a database, and then how to connect different database to data warehouse and pull the data from it. And then you will also support data analyst and data scientist, because data analyst and data scientist generally communicate with the stakeholders, so they're gonna be like a front line, and you're gonna work within backend with them. So they're not gonna have the knowledge of this cloud, how this data is getting pulled, what they're gonna be good in, how to build this different report or model, and how to present this to stakeholder. And then now now let's go what tools and technology we use in different field. So in data engineering, Python and SQL is something must needed, and it is also must needed on the interview. So any interview, they will start with Python. So they will start with Python basic data structure. Then they will go in some libraries of Python, for example. Uh, so how many of you know the Python? You can just raise your hand, like, or just react. So if you see there's a send a reaction button. Yep. Even you don't know, so we will definitely gonna teach you Python in this session. So yeah. So just so like I see there are a lot of people who don't know Python, so I will just talk about little bit on the Python. So now, Sachin, you can down your hand. It's okay now. So, so like why data and Python got famous? So now initially there were language like Java. So what used to happen is that they like these data analysts and data scientists, they are mostly not good in technology, so they and then Python offer very well flexibility, like you don't have to take care of the typing, and you don't have to, because it's a flexible typing, it's not a strict typing, like you can pass a string in the function call, or you maybe pass integer, you don't have to mention it also. So it become very easy language to understand or learn, so it become very famous in the data scientist and data analyst. So as it was growing with in demand, so it's got the eye of the industry. So now the most of the data related package like pandas, then there are scikit-learn or sklearn for the ML engineering, this industry start developing them in the Python, even though the underlying code is still in the C++, but the top layer, like which we have to use, is in the Python. So it make it easier for the people like data scientists or data analysts to learn this language, because you don't have to spend a lot of time in the learning the syntax and understanding different, like how JVM work and other stuff. So it's become very famous, and as it grows, so industry adopted and they created a lot of package which simply help each other. So now nowadays any automation you do in the industry, the Python is the first choice. Even you talk with LLM and ask him to write the code, so it's gonna give you the Python code initially, because it's easier to maintain and easier to learn. Now the in Python, we basically gonna touch about the data structure like list, and then tuple, then set and dictionary. Nowadays, a new concept has come, data classes. So we will also talk about the data classes, and then we will talk about the different pandas libraries, and then also different library to connect different database, like there's a psychob, and we will definitely go in detail about the libraries which is offered by this cloud partners. Now next come is the SQL. So now most of the SQL is basically used to query the old database. So like now data is scattered everywhere, but this database tools like Oracle, MySQL, PostgreSQL, they still are in the tabular structure. So SQL become very important lang- uh, language to learn here, because at the end of the day they are gonna be tabular data, and it's gonna be stored in this some database or maybe data warehouse. To get data from there, you need to have a good hands on in the SQL, and also it's a like any data interview, irrespective of what field you choose, like data engineer, data analyst, data science, SQL, they're gonna ask you, because it's a very it's it tells, just by the writing the SQL query, people get to know how good this person gonna be in other technologies. Now then we're gonna talk about the Spark. So prior to that there were Hadoop or MapReduce, but the with nowadays, like these Hadoop and this MapReduce are not getting much use, like legacy system use them. Now in market Spark is there. So what basically Spark is, so first initially Hadoop and MapReduce, so what used to happen that there were two things getting involved. First is your hard disk, or maybe disk drive, and RAM. So Hadoop and this MapReduce used to become slower because they have to do lot of IO operation. From IO operation, I mean you read the file, you again write the file. So in writing and reading file in your hard drive or maybe SSD is much slower than the directly doing the RAM. So now Spark come in the picture. So whole processing in the Spark goes in the RAM. So it become very efficient, or it become very fast to process data in the Spark, but it's also costly because again RAMs are not cheaper. So but again, so like in industry, people in industry like Spark for big data nowadays, Spark is getting used because latency matters a lot. If you have report in a day basis, you cannot take a time to process half of a day for just getting the report. So Spark has there. Now the next thing is you use Kafka with other processing tool like Apache Flink. So if you guys know this Netflix, so Netflix have to do lot of streaming, and then all the processing is done in Apache Flink, which is like a transformation tool. You can think is as a SQL, but for the processing tool. So Kafka just push the data to Flink and it process it. While processing, I mean it aggregate my, let's say you have data in a raw sales table. Now you want to know how much sales is happening in a real time. Like so, here you will use Apache Flink to write the code, and it will generate it. Now to run these different tools and technologies, you definitely need a infrastructure. So now when it's come to infrastructure, there are two things: on premises infrastructure and clouds. Now most of the industry has been moved to cloud because it's flexible, it's scalable. Initially in older days, industry used to have their own premises in data warehouses, but industry still have the on-premises data warehouses where internet is not available. So in outskirt, the organization which work on the outskirt, they still use the on-premises data warehouse, but they connect it to data cloud and they load data to the cloud. So clouds become one of the best best technologies to learn. Like there are like three prominent cloud: GCP, AWS, and Azure. So in this session, we will be focusing mostly on the GCP, and also we will focus on the Databricks for Spark and all. Now, why we are choosing with GCP? Because G- like what pattern I have noticed in this, now people are migrating from AWS or Azure to GCP because GCP is cheaper, and also now they are doing good very on this AI model and all. So and GCP is also very easy to learn as compared to AWS. So to enter the market, first like if you have any one cloud knowledge, so people generally even their requirement in AWS and Azure, so they doesn't bother because concept remain the same, only tools and technologies get changed. Now, if in the data analyst, so basically, as I told, like they're gonna use SQL. Now, you might be thinking what gonna be difference in the SQL use in the data engineering and data analyst. So data analysts mostly work on the select command. So they're gonna write mostly aggregation level, like group by command, or maybe having rank function. And when it's come to data engineer, so data engineer need to know everything. So they need to be good on the DDL, and then they need to good on know how indexing work, how the partitioning work, how the clustering work in this their different warehouse. So you need a very like more knowledge what like this data analyst do in the SQL. So you need to be very good expert in the SQL. And out of Power BI, Tableau, like any one is needed. Power BI is offered by Microsoft. So now most of the company have this Microsoft workspace, like Outlook also. They generally use the Power BI, but Tableau is also good too. But as this course is focused on data engineering, so we will not go in the Power BI and Tableau. Similarly to in data scientists, like they use Python, but generally they gonna use this Scala or libraries which offer model, while data engineering gonna use the libraries mostly on the like Psycho, which used to connect Postgres, DB, and different libraries with pandas, and the Spark also have this PySpark. So these all libraries we gonna learn in this coach class. And next is like MLAI engineer. So it's a mix of DevOps and uh, data role. So you need to go on Docker, Kubernetes, and MLOps. So again, we will not go much in detail. And also, as a fresher, you don't have it's not required to you to have the knowledge of Kubernetes or Docker. It's good to learn these as you grow in the industry, because then you go get the real time or industry knowledge. And again, this data architect is something not for me and not for us. So it is mostly for the introduction. So now I will go to next slide. Now I will go in, like I had already talked most of the thing in initial, right? But as I said, the data engineer, the enabler. So any data project start, you're gonna be the first person who gonna work on it. Then you hand it over to different team. And why data engineering is a foundation. So like data analyst, if data is not available, they cannot build a clean data. And believe me, data is scattered everywhere. Like even we are having the meeting, some amount of data is getting generated and stored somewhere. And then this they like now if you enable the caption, so it's gonna generate the caption. And if you start the recording, so it's gonna store. Now at the real time, data generally get stored in the high latency system, but when you have to process it, you need to pull it to somewhere where costing is cheaper, because you cannot store the data where the cost is very high. So you cannot keep everything in the RAM. You need to put in some hard disk, SSD, and all kind of things. So there, this is where data engineer comes. So once data is generated, they copy this data to somewhere, they process it, and then from the data is generated from multiple sources, and you need to load in the one place to, so people can just go and pull the data what they needed. And similarly it goes to data scientists. They also cannot work without us, because models need the data. Even you are fine tuning the model, let's say you want to change the last layer of the model, you need to have the uh, data which is like domain specific. Even you use the OpenAI model, it's need the oh, data which you want to retrain on it. So this is something I have taken from the internet. So like in the initial days, people used to call data is the new oil. So now that now data engineer are those who build this pipeline to get this oil and make oil useful. So that's what. Now, now I will talk about what is data engineering. So now, as I was saying, the data is scattered across the multiple systems and sources. So when when you read this, like data is scattered, so what comes in your mind? Like what do you think where you can have the data? Like if you guys can type on the chat, like what do you think? Like from all over the, like there are multiple system. Like for example, if I give you the example of uh, e-commerce website, so generally there gonna be three platform. One platform gonna be your, which we use, Flipkart user platform. Then there gonna be platform which sales or maybe shop owner use to sell the product or list the product. And there gonna be another platform which gonna be used by admin or maybe support team. Now these are like these. Now to have this platform, you're gonna have multiple medium. For example, you have the website, you have the, and then you have the application. Now all the application nowadays are microservices infra is getting used. So you, like everything is decoupled. So once you create the order and once you place the order, different services work on between, and these services write to somewhere like RDBMS database. So RDBMS database is like this Postgres, which are very good at uh, transactions. From transactions, basically what does transaction mean in this RDBMS? So for example, if you're doing and if you're selling the product and someone is buying it, so this gonna call as a one whole transaction. Now in between failure can happen. So if let's say whilst selling the product failure happen, so person cannot buy. So now to the date this Postgres or maybe MySQL, they are very good at keeping this asset property intake. So if there's a failure happen, so your data, the data in the database or the state of database doesn't get changed. So but this RDBMS or Postgres databases are not good at writing aggregation queries. Like they are not good at writing the complex queries. So like if you have this Postgres and then you want to create the report, you can create the report, but then latency gonna increase, and then you will see that your website is getting crashed because you are running high aggregation or complex query directly in the Postgres. In this scenario, you collect the data from this RDBMS. Now then you can load it to data lake or data warehouse, which I will talk later. Now next is come APIs. So there are different third party APIs. So what third party APIs like? Uh, so third party API is something which you take from different enterprise and use it in your their data or maybe databases. For example, if you want to create a like this OpenAI API, so how they give you a model? They're not gonna give you model in a some binary file. So they create a APIs, you pass the data to them, and internally it run the process and give output to them. Similar to it, there are gonna be different third party API like CRM tools. CRM tools are basically tools which you use to manage the customer relationship. So all the support team, like you might have heard about Joho, which is like good brand from India. So they make a CRM tool. Similarly, in industry, there are Salesforce, which are like currently rank one CRM tool. So they expose the data of their with via API. So now here there are two things, like you pull the data or you need to push it with data. Like you, if a new user come to your database, you want that user to be available on the APIs. So you also write a push job where you just push it to sales. And then as a data engineer, you gonna mostly pull the data from the Salesforce and you load it to one single places, which generally are data warehouses and data lakes. Now to build this, everything is need to be automated. So you need to create a pipeline, generally ETL or ELT pipeline. Now, what is difference between ETL and ELT pipeline is like ETL stands for extract. Extract means you pull the data. Now, in between, you transform the data. For example, your data is on a some day level, hour level aggregation means like if you have sales, so it will tell us like in each hour how much sales is happening, but your requirement was to present in the day level. So in between you will do the transformation where you just convert this sales information to day level, just by it might be simple SQL query, and then you load it data. So this is called ETL because you did transformation in between. Now newer approach is ELT. So you extract the data, you load it to some places without doing the transformation, and later different pipeline do the transformation. So now out of this, now the industry has moved to the ELT because ELT also offer the flexibility to reprocess the data without pulling it again. For example, now current requirement was to do in the day level, but someone again in future came, okay, we want report in 12-hour basis. So how you gonna do in the ETL? You need to again extract and you again have to transform the data and load it. But while in ELT, as you extracted and load the data in the raw format, you just reprocess from the transformation part. And now the generally data engineers don't do the business transformation. They mostly focus on the cleaning or maybe data standardized or maybe normalize the data. So that's the data engineering work. Now storing and cleanse. So for storing the data warehouse, there are two main technologies: data warehouses and data lakes. So what in data warehouse, the you can, if anyone of you or heard about BigQuery, or you might have ever heard about the Snowflake or Redshift. So these come under data warehouses. They are good for like storing structured data, and then also some level of semi-structured data is also supported when it's come to unstructured data. Now, unstructured data is basically your image, your audio, your text. You can store it, but you need to process it and make it some similar to what data warehouse expected. So in this kind of data, you generally use the data lake. So now data lakes is basically GCS. You can have your S3 simple subject storage like S3. You can just pull your audio file or text file or video file and load it in the data lakes. And similarly for data warehouses, generally the tabular data, for example, data you load from the RDBMS, multiple RDBMS to data warehouse, and later like people can use both to use like join the data and create a report. Now the next role, as I initially said, that you also need to support the infrastructure and infrastructure on data, like whole data level. It's not gonna only for data engineering. So what like as data is growing, so you need what kind of infrastructure you're gonna manage. So basically, it's mostly gonna be going to be your warehouses, how much memory it's required, how much storage it required, and then also the optimization. So nowadays most of the warehouses charge you in the how much GB or TV of data you are scanning and how much you are storing also. So they charge on the both. So when you I say scanning, let's say if you are running the query and to get the output of that query, you need to go to table which have 1 GB of file. So but like how you gonna optimize it? So then the things like partitioning and clustering comes into picture, because not every time you want someone to run the one query and it's again scanning whole data, it's gonna pile up your cloud bill. So use so this kind of thing also you do on the data engineering. You need to educate the data analyst or data scientist how can they optimize their query, and you can also you need to be responsible for how tables should be optimized. So someone run the query, it should only scan the data which is required. And when it's come to storage, so most now there gonna be some hot storage or cold storage on standard storage, what we call it in the S3. So standard storage is basically which gonna be costlier. So it's good for the data which needed on daily basis. But let's say you want to load data for some auditing purpose, like generally this compliance, they required you to store data for 5 years for historical data, but then it's not gonna be used daily like you. So generally then you move to archive storage. So this kind of decision you need to do, like when we will say this data is not needed more and we need to move it to archive folder on. So that's how what as a data engineer you do. It's a complete data engineering. But in industry mostly you work on some part, either you will work on the ETR or ELT pipeline, or then you will work on the infrastructure. When like generally in enterprise you have this separate role for this, but if you go in this work in a startup, then you might be responsible for doing everything. So it's good for learning. Now these are small slides where we're going to talk about the evolution of data. So as like the computer becomes like where like before 1960s and all, there were paper based era. So though those were used to we used to store data in the physical book. So you might still see the government office where you have lot of files and all. Even you go to government office, they are also moving to from the this paper based. Now they also started using this computer and all to store your data. So Aadhaar card is the best example. Or you do any land registry, so they also gonna store it on the computer and all. But before 1960s, it was mostly paper based era. So data was stored in the physical books and all, and it was kept in somewhere. Now then, between 1960 to 1990s, when this computer and everything come started the picture. So this day like digital databases era started, where you have this SQL and relational database. Now tabular data become the is easier to store in the SQL data. Now when in 2000 the internet era came and that .com thing comes, so then there were a lot of website was getting built and also there were a lot of data started getting created via the internet. Now next, like in 2008 or maybe before it, when Facebook and everything started, so you have lot of data other than the tabular. Then maybe you started posting the images, text, everything started going to internet. So now the big data came in the picture. So initially, like if I remember, so Facebook was not able to store this data, so they created this Hive meta store to store this data and all, because the RDBMS data are good, but they doesn't scale horizontally. Like Generally, there are two kind of scaling. One is vertical scaling. So what scaling? Like take your computer now. If you want to upgrade it, you go to shop owner and you said, I have 8 GB of RAM. Just add one more RAM of 8 GB. So it's gonna be same computer, 16 GB RAM. But at after some instance, like your computer not gonna support more than 16 GB RAM. So what you gonna do? So you might buy the external RAM and use it. So that's what horizontal scaling comes. So like as soon as the you cannot vertically scale, you start going with the horizontal scaling. But again, it's there are challenges is in horizontal and vertical scaling in both. So like generally RDBMS are still people prefer to be in vertical because it's they need this acid properties which we're gonna talk later. And then for this computational or maybe for big data, generally they go with horizontal. So Spark is totally distributed system. So it distribute in a multiple nodes and vCPU to do the processing. Now after that, this big data came. Then initially the this hive something which started, it was more on premises thing, but again the data was getting generated in a huge quantity. So people start moving to cloud like AWS. So generally in cloud, there are gonna be multiple services. Like for example, in GCP, I talk about, so there are services like Cloud Run. So Cloud Run basically used to host your website front end. And then there are services like uh, BigQuery. BigQuery is something related to data. Then there's a Cloud SQL, which where you can spin up the Postgres instance and connect your website. So it's both for the data plus the software development or app development. And so if I talk about it specifically on the GCP, uh, I will share different screen. So these are all the services available. So I already talked about the BigQuery. So it's for the warehousing. The Looker is something visualization tool is similar to the Power BI, but it's not much adopted in the industry. Dataproc is something uh, is running the Spark job, Apache Spark, but now this Databricks has lot of precedence over it. So we will mostly don't talk about Dataproc, but we will talk about Databricks because it's a very like every data engineer job requirement, you will see the Databricks as a uh, requirement. So it's good to know. Data flow is like similar to Apache Flink, where you build a real-time processing pipeline. Now this Cloud SQL, which I talked, like this MySQL database and PostgreSQL. So now there's a Cloud Spanner also. So both are similar, but Cloud SQL is basically it's only for one reason, while uh, Cloud Spanner is basically for multiple reasons. So if your business in, let's say in India, so you don't need a multiple reason support, while let's say you have business in the US and then also in the India and then you also in the other part of the world. So you need something which have multi-region support because same user data need to be available on the user on the like database on the US, but you also need to make sure the latency is high because if you deploy, let's say you select your data center in India and someone access it in the US, they're gonna be very high latency. So user experience gonna be very bad. So to this kind of, if the requirement is this, then you need a cloud spanner. But we will not talk much about it because it's more on like a, it's like no one expect you to know this at the initial stage. So mostly these kind of thing you learn on the industry itself. Now, Cloud Big Table is a time series database. So also Cloud Big Table, YouTube use it to store its data and everything in the Cloud Big Table because it's very, very efficient in storing large number or very like big data thing. Now the cloud storage is stored to object. So any text file, any audio file or any image, it go to cloud storage. So we will talk about this also in and the AI world. Now the Vertex AI now it's mostly for the AI engineer, ML engineer. They use this Vertex AI to fine tune the models and all. They also have the Gemini and everything. So, but again, this is not something related to data engineer, but it's good to know. Now again, back to my slide. So currently this era is going. So we are mostly going into cloud data era. Now let's say in future how it goes. So you will now the AI model are also there. So vectorized database are also coming because AI models. So now the biggest challenge is AI data and AI model have that we write in this NLP, but they don't understand the NLP. They don't remember the context. So every time you write something, so they're gonna again parse it every information and then build. Then they give. So now this in the market there's something vectorized database is coming where you already had the data stored in the vector format, which is easier to understand by AI. So it's something coming in the market, but again, it's they're gonna be this takes some time. Next, I will go in the different type of data. So, like I have mostly talked about you, it's not something like again, but again I repeat it. So, structured data. So basically anything which is in your tabular form. For example, table at your MySQL, Excel sheet, or financial transaction. So generally the OLTP database. So there are two terminology, OLTP and OLAP. So it also asked in the interview like what is difference between OLTP and OLAP. For now I will just give you basic difference. So what is the basic differences? So this T stand for transactional and and OLAP is in OLAP it stand for analytical. So any database where you have very high compatibility with the transaction. So transaction I already explained you that if money is deducted, so it should be credited in somewhere in the account. It should not be that money has deducted here, but it hasn't credited in another account. So it's like it's not. So any database which comply this whole, it's called it's come under the OLTP database. And now what are those? Like that, then there's a MySQL, then there's a Postgres, now Oracle. Now the Postgres is getting increased in the use while MySQL and all Oracle now industry is moving out of them. Now what and also the transactional databases are very efficient on inserting the query because you need to update data in very high frequency. So inserts and these commands are very good. When it's come to OLAP database, so warehouses like BigQuery, Redshift, these come under the OLAP database. So here you can write very complex queries where you do joins, you write recursivity, you write this rank function, but they are not efficient on the transaction. So they doesn't guarantee like if something goes wrong between, so another table will or other they will maintain this acid thing. So this is a OLAP database. Now next is semi-structured data. So semi-structured data is like JSON data. So now this cart system or maybe product catalog. So product catalog, basically you have this in e-commerce website, you list different type of product. So all the information, so they doesn't have fixed schema. For example, uh, you are listing the book, so book might have the author name, or you have the number of pages, anything. But let's say you want to store it, any mobile, so it will have different parameter to be stored. So this kind of thing getting stored on the NoSQL database, and generally in JSON. So because they don't have the fixed schema, so they are flexible. So generally, like in product, you have different categories of parameters. So product catalog are maintained in this semi-structured format. So what come in the semi-structured, like first, as mentioned, JSON, then there are XML file where which is just it's similar to some file where you just write the uh, syntax and then it get passed by the XML parser. The YAML also is something we use for the configuration. So like these can be used like you can use JSON as well XML and YAML. So most of the coding language support parsing it out. It's not like something, but then again, if you are using any library, it doesn't support the JSON or YAML, and what you need to use what they support. But when it's come to the pulling the data, you might get the uh, like if you're working with the API, so API generally return data in the JSON format. But if you are working with some internal product, generally configuration are maintained in the YAML, and they ask you to pass this. So you're gonna use the YAML parser to do. Now the in unstructured data comes unstructured data, basically text, uh, image. So now text can be come from anywhere like PDF document and video, audio, image. For example, this PPT is also unstructured data, and someone in tomorrow comes and want this information to be stored in somewhere. So you will store it either by parsing it, or generally you store it in the unstructured. For example, uh, and I have built one pipeline where user used to upload the PPT. PPT used to be something their pitch deck where they come to use and pitch you their idea, and we want to store it. So it used to store this PPTs in the data lakes like as GCS, and also there gonna be some information like contact number or maybe username or email ID, and then this file name. So it used to get in the data warehouse. So it was combination of both structured and unstructured data. So this kind of pipeline also data engineer would. So it's something which I had done in past. Now, so I have put some numbers like how much data these big enterprise are generating. So this number is from the internet. So now the Google generates around 20 petabytes of the day, which is like 2 million GB per minute. Now, the if you think about the scale, it's a very huge scale. So in backend, there are gonna be n number of data engineers with DevOps who are working it to store this data. Now, generally, whenever you store the data in this big enterprise, you also have to make a backup of this data. So something get failed, you have the backup. And also if it is a multi-region, you have to do run the cross tunneling and do the multi-region thing. So data is available in each region. So now with this huge skill, there are a lot of requirement for the data engineer to know how you gonna work. So similarly Netflix, so Netflix mostly work on the, so this is streaming data. So like this, you watch any movies in the Netflix, so it getting streamed. So streaming data is basically which doesn't have any end. It's continuous stream kind of thing, like the water pipeline. So water, if you open the tap, it will continue to flow the water, something like that. So the entire Netflix library, which is basically their go you videos, web series, it's come around the 3 to 5 petabyte of storage. And if you see this, now you can access all this via your mobile application. So all this data is stored somewhere, but when you access it, like even you search something which movie which have been uh, released in 1990, it will be available for you in a second, and without any latency you can watch it. So this kind of scalability and high efficient pipeline you need to. So so these companies are like well known, and then lot of like Netflix something created a lot of open source product. So if you know this Airflow, if we don't know, so we will talk about it. But basically Airflow is a orchestrator, like it's a tool where you schedule this pipeline where it gonna when it gonna run, and there's gonna what task or what pipeline it gonna run. So this kind of thing you can do in the Airflow. It's also uh, like the top 10 open source project in this OSS rank. So this basically was initially created by Netflix, and then they open sourced later it. Similarly, they also offer this Netflix tech blog. If I don't know if you guys are aware, but it's if you want to know what happening in the Netflix, so you can always learn and go and read it. I also do. So Netflix tech blog. So where they talk about how their infrastructure is they are changing. So it's good for knowing the knowledge and everything. So might have talked about the data skill. So this something it's good to aware what happening on the industry and all. So that's something I want to share. I will again go back to my presentation. Then YouTube never go out of the storage, because I also don't know how, but again they have some good system where you can store n number of the files. Nowadays people also use YouTube to store their video, YouTube and everything, so they can come and use it like 10 year after. So days so you can see here that how the data is growing. And we will again go back to data engineering project life cycle. So how actually you work with the data engineering project. So like some initial, so this is the discovery and design, it's gonna feel every project. So like it depend on, like even you become a software developer, or you need to talk with the stakeholder or maybe project manager, product owner, to understand the requirement, what they want to build, and what you gonna outcome. So here, generally, you talk with the product owner, you talk with the project owner, and then you also talk with your user who gonna consume the data, and then you also talk with the data architect. So everything go with the data compliance, and you expect and also you talk with the user. So user is also aligned what they can expect and what they cannot expect with this data. And project and product owner generally take the require from the business what they want, because like data engineering the first stage of any project. So uh, generally every project start, any data project start with the data engineering. Now next you're gonna set up the data architecture. Now when it's come to setting up the data architecture, let's say you are building any pipeline and it's a Spark based pipeline. So Spark generally requires a lot of compute resources. So all this, and then you gonna do the some preliminary analysis. Let's say you have to process 50 GB of data in a day. So how many computers or CPU node or V node you require? And then once it you ingest, and then you also have to ingest the data. So ingestion is basically, it can be from anywhere, like this need to be discussed on your design phase, like how your data gonna be ingested, what gonna be source. Generally most of the time you source is gonna be API or maybe some internal databases. So, and also like IoT sensor. So if you go to now, this EV vehicles are coming in the picture, so they also generate data in their bike or maybe EV car. So they also get synced to servers, they got also stored. So now these pipe, so there's gonna be sources, and you need to create a pipeline or architecture which is like highly scalable or efficient with latency and all. Now when it's come to the transformation, so generally in any data project there gonna be three layer. So what we call is the medallion architecture. So medallion architecture basically, it's a concept where first data is stored at the raw is a called as a bronze layer. You don't do any transformation, you pull data as it is. Then it's the next come is the silver layer. Silver layer, you standardize the data. From the standardization of the data means, like if you have data in the same structure or be nested. So for example, I will just share how the nested data looks. Yep. Nested. So if you see, this is a nested data. So basically it's a JSON data. You're gonna work a lot. So it have article ID. So if you see the tree, so these article ID, article link published on source are at the same level, but then it's come article. It again have the uh, numbers of different key and value. So this come under the nesting. And then sometimes there are very deep level nesting, so you need to work and pass this data as much as you can standardize it. Like if it is possible, you have to have in the one level nesting, then it make, like generally user expect is in a one level nesting, because they don't want to spend time on writing this unnest queries and all. And then you also do the cleaning, some like if any data is all like it's doesn't make any sense, you're gonna remove the data or clean it, or maybe for example. And then you also do the validation. Let's say if source say this need to be email, then you will run the email validation there the ईमेल ईमेल लाइक एट द रेट होना चाहिए, और कोई ऐसा कुछ नहीं होना चाहिए कि जो ईमेल जैसा नहीं लगे. सो दिस काइंड ऑफ वैलिडेशन यू आल्सो नीड टू डू एट द सिल्वर लेयर. And then it's come the gold layer. So gold layer generally built by data analysts. So basically what they do is aggregate the data. So they group by, as I earlier told, like they might create a sales report on the day level basis. Because generally whenever you pull the data, you try to pull at the very low granularity. Like if data is available in a minute level, then you will pull data in the minute level. And why we do so? Because from minute you can go hour, you can go day, but from day you cannot come to hours and minute. So it's always a good thing to start with the basic granularity. Now the next is automation and retries. Now here airflow comes in the picture. So airflow is basically where you just orchestrate and automate it. So you, like if you create a pipeline, you're not gonna run at manually at any time. Like there should be some tool which orchestrate it out. So currently airflow is leading it, and we will also learn about the airflow in the later stage. And now, so generally now sometime you have pipeline A, and then there are pipeline B and then pipeline C. So they are gonna be dependency that pipeline A should run, then pipeline B should run. Or maybe it's like if pipeline A is failed, then you trigger the pipeline B, and something this kind of dependency you create with the help of airflow. And also the retry, something you might get error which is not due to, which is like a temporary error. So retries help. Let's say you have this something is issue in the source side, like somehow there's infra was down, so you can retry sometime help it. So we will also talk about retries and different type of retries. CI/CD we will briefly touch about it, because CI/CD is basically it's cover everything, cover in the everything. Let's say you build a pipeline. Now you have to deploy. Deployment means like this pipeline should be as soon as you complete your development. It's need to go to different environments. So industry generally we work with the multiple environments. So they are gonna be production environment, then they are gonna be one testing environment, and also they are gonna be development environment. So every time you build something, you don't directly go and deploy to production. You first deploy to development and pipeline, then for some day, then you look into the data if there's any cascading effect. Like say you build it and you are not aware of that, with this change something else will also change. So on, so you run it to development environment and look for if you find it out something. If not, then you move to the testing environment where you run with the more huge amount of data and testing environment, and then some QA will be there which will test it out, or maybe you will have write the quality checks on it. Once everything look good, then you go to production environment. So now to have, now there are three stages. So you will build CI/CD automations with help of either GitHub Actions or Jenkins to this deployment process. And then you also write the unit test. So we will this unit test and all everything we will cover when we learn the Python. And we will briefly talk about how this grid branch deployment work, also the schema evolution. So schema evolution is also v- very like schema evolution. Basically this is like every time you deploy the change, you need to always make sure the schema evolution policies are intake. So if like what is a schema evolutions, for example, initially you started the pipeline with 6 column and you made the change, and now you have 7 columns. So this come under the schema evolution. So you need to maintain this schema somewhere, or either you let the pipeline do schema evolution like automatically, but this is not preferred in the industry. So generally you maintain the schema. So to nowadays, like something coming in the picture, data contract. So this we will also talk about, because it's becoming very hot topic in this data market. Like because previously what used to happen, that source team used to add a column. Now as a consumer, I was not aware that new column has been added or maybe removed or maybe renamed. So it is the my pipeline is to fail, because so source team hasn't made any communication to me. So now what industry is moving toward, they create a one central hub where they're gonna have this data contract. It is maintained by the producer who produce the data or who is a knowledgeable in their data. and it's also maintained by the consumer. So he know, so every time there's change in the schema, producer will update the data contract, and then consumer will consume it. It also have different parameters like SLA, like if this 5 is failing, how much time the producer will need to fix it, and also all the different configurations. So now the this is coming the in the new, something new in the data engineering. So we will also talk about this. So this data contract help in lot of things, like it also help in your schema validation, then you also maintain the quality checks, also different things. So now this operation in delivery, so once the pipeline is ready, it's become your responsibility to fix the pipeline, and uh, how the data set gonna expose, like, and data should not be like the all the governance, basically who can access the data, it's need to be maintained by you and everything. So generally nowadays, like with this data contract coming in the picture, so this is something we start doing in the data contract itself. So we will talk like how to build the data contract and all, like, so date when it's come to the data processing pipeline, so generally in a majorly there are gonna be two pipeline: batch processing pipeline and real time pipeline, also called as a RT. And there's also an RT which is near real time. So most of the things are near real time. For example, the cricket match we watch, it's also not the real time, it's also near real time, because there's some latency. Now batch processing pipeline, 90% of the time we build the batch processing pipeline. Real time processing pipeline is, there are very less, but it's also require very deep knowledge to build real time processing pipeline. But as I at the like in the 6 year of experience, I have only wrote 2 3 real time pipeline. So most of the requirement are in the batch processing. So we will talk about the real time pipeline, because people ask on this interview, but we will not go in detail about the real time processing pipeline, because no one expect you to know this Apache Kafka, Apache Flink at the initial phase of career. Now, when it's come to batch processing pipeline, so what is batch processing pipeline? So data is collected in the interval. You don't data collect the interval as soon as it available. So you might running the pipeline in a day level, or maybe in a uh, 6 hour level, or maybe weekly pipeline and monthly pipeline. So this have like high latency, like as the data is not available as soon as it generated. So it's come in the high latency, but the data is very massive in volume, and then you run the complex transformation across the historical data sets. So here you combine multiple data sets and then generate report out of it. So now to do this the batch processing pipeline, there are tools like Apache Spark, and then Snowflake is basically it's a data warehouse, but also it's offered you the transformation and all. And then DBT is also open source. So mostly we will focus on the Apache Spark, and I will talk about the DBT, and then Databricks we will focus on the detail, because these are like some company use it, but some doesn't use it. But this Apache Spark is like a foundation. So it have more jobs in the market as compared to a specific tool. And also Apache Spark is open source. So when it's something become open source, so more industry adopted, while Snowflake is like a enterprise thing, so it depend on the company to company. While DBT is also open source, but it's a layer in top of SQL, or maybe Apache Spark. So basically, what it help is basically instead. So in the older days, like if you have to rewrite same SQL query, so you need to copy paste same thing. So DBT help it to SQL to make it more modularized. So same code, you write it somewhere, you import it, and you just update some parameters, and it will run. So if you are, let's say you want to write the group by in query in the some query column, so you create a DBT macros where you pass the table name and at what column you have to do the group by. It just you don't have to write the whole group by query again and again. Just call it and pass some parameters. So there DBT helps. So we will also discuss little bit on it. And then we will also build a one pipeline. It might be e-commerce pipeline, but it can be different. It we will see as per the as we proceed further what we will do. But for whatever we will gonna do, it's more gonna be something from the industry. Now the real-time processing pipeline. So this pipeline, like it's there in the market, but again it's require very high knowledge also at the initial phase of career. uh, no one expect anyone to know how to build a real time pipeline, because everyone for this kind of scenario they want someone very experienced. So but the low it real time pipeline are generally very low latency pipeline. So this credit card fraud detection and all. So basically, I don't know if if you go and use, if you haven't done any US dollar transaction from your credit card, and if you go and suddenly do it, so you will, in a second, you will get a call from the bank that you someone is trying to do the dollar transaction from your account, and they will confirm if it is you or not. So how they are knowing? So in backend, what happen is basically, so in the near real time processing pipeline, they take both historical and the current data. So as soon as you did the transaction, so they will check your historical data that in past if you have done any dollar transaction or not. If you haven't done, then it will trigger an alert to the maybe call sales team or maybe customer support to check with you that you are doing it. But again, if you do this, yes, now you have done, you said yes, okay, I had done it. Same thing not gonna happen in the next time, because now in your historical data there is a $1 transaction. So that's the something like this, something I had noticed in past when I was trying to do some dollar transaction in this collab and also. That's how this pipeline will work. So it take care of old data also and the current data, but the current stream of data is not in the high quantity. Let's say IoT device, so it's getting consumed in the real time. So the data size gonna be less, but again you gonna store this data in somewhere, and the transformation pipeline take that data and transform and create a alert or maybe report out of it. So it's come under real time processing pipeline. So now other example is like this hot star, and also they show different angle picture or maybe shots and all. So this come under the real time pipeline also. But if you might have noticed that sometime they generate this ball tracking and all, but it get delayed due to some issues. And also that's there are some challenge on real time processing pipeline also. But yeah, but like most of the industry focus on the batch processing pipeline. Real time processing pipeline is there, but it's not like good to at the start of the career. It's okay if you even don't aware of it like in detail, but we will definitely talk in little bit in brief about the real time processing pipeline. Yep. So this is how the in detail real time processing pipeline look. So source emit the data. It might be IoT device or sensor or maybe some app logs. And then some like Kafka or maybe Google pubs up, pull their data and ingest it to somewhere, and then there's stream data real time engines like Apache Flink which process the data, clean the data, and this data is enrich the states, which is basically same transformation of the data, and then it either load to sync or maybe it deliver to like alert action. So the what what is the requirement of real-time processing pipeline? So the latency should not be high, and it should be continuously running, and unbounded data set. So unbounded data set is something which doesn't have the tail. For example, IoT device, so it's gonna continuously emit the data. For example, this weather sensor data, it's continuously emit the data. So and it's get it loaded somewhere. So there are some tools, tools used for something different. So for ingestion and buffering, which is basically Apache Kafka. Kaf, Kafka is open source. Then there's a Kinesis. So Kinesis offer three different services inside it. One is for video processing, and then another two is also there. And Google, you only have this PubSub. So PubSub basically work in publisher and subscriber method, where publisher push the data and then subscriber can pull the data. Now when it's come to processing, then there's stream processing engine, basically Apache Flink, which is like which is best in the market currently. And there is Spark streaming. So Spark streaming is used by this Visa and Mastercard for getting fraud detection and all, and Kafka stream and all there also is there. Now for this, like there's a storage and warehouse, so ClickHouse, Pinet, and Snowflake, and then BigQuery also have stream table, and Databricks also have this stream table. So these are for the storage and warehouse. Now after that, like from here, you can also directly push to another event bus like Apache Kafka and all for the alerting, or maybe something like it's not necessarily you store it, but generally most of the time you store it for the historical purpose. But from there you can also have the uh, another flow which basically do the real time thing. Now the orchestration and monitoring, it's just to monitor your pipeline, because how you will, if something going wrong, how you will know that something is failing also. These tools come in the monitoring and all. Now I will talk about what we're gonna learn in the Python, like in the course. So like in upcoming weeks we will start with the Python, and then we will go with the SQL. So with some weeks we will talk about the Python fundamental, which where we will initially talk about the variable loops, how to write a function, how to write a class, and then how you use the lambda. And then I also talked about the data classes. Then there are generators. These all things we're gonna cover, and then we will also cover about the OOPS basics. Then next we will also talk about this pandas and NumPy package to load this data, like, and how to work it. Then we will also talk about the how to work with different kind of file like JSON, CSV, or Parquet file. And then we will talk about the data cleaning, like how you handle the nulls value and how you transform it. And then next we will also talk about how to access any databases, how you consume the APIs, and then how you will make a Python only ETL pipeline. Then we will talk about the SQL database. So here we will talk about the how to write the basic queries, and then we will cover about the joins and unions, aggregations, And then in aggregation, we will talk about this rank functions, and then we will also talk about something recursive CT and CT, then the how you different functions and functionality available in this SQL. So this we will briefly talk about because you need to know how the modeling works. So ERD diagrams, how to read the ERD diagram, what is this normalizations. Also, we will talk about the slowly changing dimensions, basically. Uh, and then DDL, DML command, how constraints work, what are primary keys and foreign keys, and this everything we're gonna talk in the SQL. And in between, we will also have some homework where we will uh, ask you, like for example, if we are working on the Python fundamental and fundamental is done, so we will give you some questions which is getting asked on the interviews to write the code. It mostly gonna be from the DSA, but not very advanced DSA, because in data engineering you need to know about the DSA, but you need to be very very expert in the DSA. So we will it give you the question and then also help you how to solve and understand this kind of question. Similarly, we go with SQL. So we will start with basic, go intermediate and advanced. Now then we will talk about the Apache Spark because it's a must to know thing in the data engineering field. So Spark, how the Spark infrastructure work, what is different component in it, and then how you can optimize the Spark job, what are data frame and the Spark SQL, and then how you tune it. This we will talk with Databricks. So here we will learn with Databricks, also Databricks concept also, like Delta table, and then Spark declarative pipelines and all. We will try to cover that as well. When it's come to the cloud infrastructure, so we will mostly focus on the GCP and Databricks. But like similarly, like in AWS, you have similar technology which is similar to it, but we will not talk about it much in this. We will give what is equivalent GCP, AWS services and GCP services similar to the, because it in now like Databricks is taking over in most of the scenarios. So whatever data services GCP and AWS was offering, Databricks have them. And now the Databricks company is owned by the person who created the Apache Spark. So now it's very good to know Databricks because it's getting built by someone who created the Apache Spark itself. Now this gonna be continuous process. It's not like we're gonna do last. So like if uh, whenever we will teach, we will try to communicate in a way that what is important for your interview, what is not. So you focus what is important for the interview. Also to like like to crack any interview, it's not necessarily you need to be expert. You need to be good at lying. So even you don't know, if even you don't work at the this technologies, have industry knowledge, but if you while interview, if you make sure that interviewer is convinced that you know, then your job is done. That's how we will try to make your mindset that whenever someone asks you the question, how you gonna answer them. Because like each topic is very vast, and covering in in 6 months not gonna be enough. So we will focus mostly on like the interview. It's gonna be focused on the interviews, like how they ask. Similarly, like there are gonna be on demand panels if you want to schedule a mock interviews before you go to the interview. So you can definitely communicate with us. We will schedule a mock interview 30 minutes or maybe 1 hour where we will give you DSA and maybe ask the question as per the JD, and then team will also help in this resume optimization and everything. I think that's for today. That's it. Like we are around like 11:45. So that's what I have to for the first class. From the next session, it's gonna be very deep. So first class gonna be on the Python. So we will learn Python on the go. Now I will take some question if audience have some questions. You can type or you can unmute yourself, and you can communicate in Hindi or English, whatever you are comfortable. If you don't want to ask, then you can definitely reach out later as well with your questions. So, like whoever is your POC, point of contact, just communicate with them so they will help you to connect with me, or maybe they will answer. No question in the call. Yep. We will, from the next session, we will definitely go with English and Hindi. But again, the like Hindi we will teach, but again, like you need to be good at like at least basic communication in English, because interviewer like don't expect you to have talk in the Hindi. But again, this course our purpose is to teach you, so we're gonna definitely talk in both language.
So actually, sir, it was a very long theory session.
Yeah.
So from the next class, we are doing practicals as well, huh?
Yep. So from next class we will start with the Python, and we're gonna do the practical in this Jupyter notebook and everything. So current session was more of the introductory session. So where we want to let you know what you should expect and from this course, and also that's what we wanted to do.
Okay, sir. No, actually, because it was very hard to concentrate in a
Hmm.
very long theory session.
Yeah.
Actually, that's
Yep.
why.
Yep. Yeah. From next like session, we will take the some breaks also in a 1 hour interval. So this time I forget, like, so yeah. For next session we will take some 10-minute breaks in between, so you guys can have a water and restroom breaks and also. But definitely the thing's gonna be more focused on the uh, how you write the code, how you do from the basics to advanced, and it will be focused on the Python and SQL. So now why we initially starting with Python, because like interview process should be continuous. So as soon as we teach the Python, you are ready to go in the market and interview for the Pythons and all. So here we want to make you ready, because the like I have 6-7 year of experience still in the market. Initial round on the Python or SQL, they go very deep now, but so not like even the AI has come, the initial round of the interview is gonna be same Python, or maybe your preference of language. But again, like for interview and all, I generally prefer the Python, because you are time bounded, so you don't want to spend time on fixing the syntax error in the Java, and also that's the thing. And also if you leave the top company, most of the company doesn't focus on the how efficient or how much less time is your code is taking. They are focused on if you are able to approach the idea, and if you are able to write the code. So even I tell with the DSA example, So you don't have to solve the thousand of DSA lead code. Even you solve that lead 75, like if I don't know if you guys are aware of this 75 question in the lead code. So if you search this GitHub lead 75, so if out of this, even if you complete the 30 40 or maybe 20 30 questions, so in the most of interview you're gonna have the similar kind of question and you will able to solve it. So like this array hashing and 2 point and sliding window. So like this linked list, like it's never been asked with me. Like, so generally people ask with the arrays, 2 pointers, and then string. So so if you search this blind 75, or there's also this website neatcode.io, where this person also have the YouTube video where he explained very in detail how to solve. So from here you can also see he has maintained this. So if you open each of section, there gonna be different question, like this contains duplicate valid anagram, two sums. These are something people ask still. So now out of this, even you don't know this is valid Sudoku and all, no one cares about. So you you like if you're preparing for interview, you come here, you see, and also look at this lead 75 or maybe blind 75 question with Python. Just for the DSA, focus on this. Like you will able to get in the good product based company with just 75. Now if you go with this fang, then you have to definitely go out of lead 75 and prepare very in detail with this lead code. Like, so but again, like at the initial stage, it's better to focus on getting the job instead of getting the best. Yep. Otherwise, if someone don't have any question, other idea also, like, because I believe most of you are the fresher, as I have been communicated. So you might be preparing for the interview. I don't expect you are not. So for SQL, this starter search, you can log in here. You can, like, you can see the data engineering question. So this is also good website other than lead code. So it's more focused on the data side. So this website you can definitely check. So I will say here, if you are not aware, then it's definitely good to start on this website. And it's like, and also most of them offer the free tier, which is enough for the interviews. And also the interviews process is rigorous. So every time you go in an interview, what question you have been asked, just copy it and keep it somewhere. Like, that's how I used to do and I still do. So I have like around question from this 20 to 25 companies, like, who asked me this SQL and all. I will share that also later. But yeah, for now I just this. So yep, that's it for today. So we will see you in the next class, maybe in next Saturday. So there's gonna be more focus on the Python and everything. So have a great day, everyone. Bye bye.
Okay, bye, sir.
Thank you, sir.